Good afternoon, everyone. This is Ali Mastardo, Senior Association Manager of ISSA. Thank you for joining us today for ISSA's Leadership Development Team's webinar. We do have you all on mute for the webinar, and we'll be using the question function for any questions. The questions will be answered at the end. This webinar is being recorded, and a copy will be sent via email to all registered attendees and will be available on the slurry.org website. I will now turn it over to Joe Brandenburg and Jamie Wing, the chairs of the Leadership Development Team.
Hi, this is Joe Brandenburg. So today, Tyler Key, who is currently with Bergkamp, is going to present for us. He currently serves as the North American Territory Manager for Bergkamp. He has served in this position for more than 3 years. In this role, Tyler is responsible for the sales of microsurfacing and slurry equipment, the Max machine, patch machines that go to contractors across the continent. Tyler is also responsible for quoting, follow-up, establishing relationships with customers who are both current participants and looking to enter into the industry. Before joining Bergkamp, Tyler was employed with Vulcan Materials for 10 years as their senior sales representative. His responsibilities were all aggregate sales in the central Mississippi area. Tyler currently resides in Mississippi and is married to Marley Key for 8 years. He has 6 children: Jordan, Brooklyn, Charlie, Emma, Ludden, and Kane. Please welcome Tyler.
Good afternoon, or happy noon, gentlemen. Thank you for the introduction. Joe, I appreciate the opportunity to speak with you guys today. And just a short topic we're going to cover today is the 5 keys to a quality microsurfacing project. As Joe mentioned earlier, my background is in several aspects of the construction project, being from aggregate, even on the bonding and insurance side for a brief period of time, and now in equipment. So I look forward to speaking with you guys and going through some things here over the next 45 minutes or so. I don't know if they mentioned earlier, the questions can come at the end. We'll have plenty of time to cover those. If for some reason I do not have an answer, we will make sure that we get with someone who does and get back to you at a convenient period. So there again, thanks again for the opportunity, and that we'll get started here. So the 5 keys to a quality microsurfacing project. Just a few things here. As you can tell, quality is the goal of any project for contractors and or the agency or the owner of the project. We all have the same mission at heart when we get started. It's how do we get there? Sometimes there's some meat in the middle on how we get there, and that can be discussed and hopefully worked out in the process. But for today's purposes and today's goals, there's 5 keys. There's 1,000 others, but for today, we're going to discuss these 5, being 1 is the equipment. We'll discuss equipment, different types of equipment, how those different types of equipment may work, what they may be able to do or not do to be successful for your project. We'll move on to materials and calibration and how important each one of those processes is in this procedure. Lots of materials go into this application. You can have the best materials, you can have the best everything, but if your calibrations are not done or not correct, then none of that's going to matter in the end. We'll talk about some surface preparations and things you can do beforehand to make that job successful, and if they're not done, what it can lead to. Different ways of paving and different applications that can be used to make the job successful, and then again, the problems that we see in most micro jobs and what we can do to fix them. So in saying that, we'll jump into the equipment and start from there. So what is a slurry paver? So a slurry paver is a lot of things all mixed up into one box. If you've been in hot mix, you know that there's a lot of different applications and different equipment and needs that you need to be successful and to process that job and to produce that job for the agency or the owner to be successful. So we got a pile of a truck here bringing rock to or from a job site. You got your hot mix plant where all of the materials needed for that job are brought to one central location and put in and come out at the end for your 9.5, 12.5, your HMAs that are needed for the job. It's just kind of out of order, but there's your roller at the end, making that road nice and smooth, getting that bonus, that ride bonus at the end of the job. and obviously your paving equipment that's on the road laying down that mat. So when you take all four of these things from a hot mix application, when you're talking about slurry equipment, what you have is an all-in-one package. So what we're looking at here is a continuous paver. You got all your materials in the front of this train, as you can see with the truck up front. That tank on the right is also duplicated on the left. You got emulsion on one side, you got water on the other, you got your rock. So you got all the things that hook up to this equipment and turn it into an all-in-one package. The materials delivered to the white piece of equipment here. It all goes through the hoppers, through the emulsion pumps, the water pumps, everything needed to the plug mill in the back for a finished product that will be delivered to the slurry box or micro box on the back of the machine, excuse me, for that finished mat that you see going down on the road there. This is our truck mounted pavers. You'll see different varieties here. The one on the top is a no side engine piece of equipment to meet tier 4 capabilities. The one on the right, in the bottom right, is it would be considered tier 3 or have a pony engine that's driving the application. Both of these products are doing the same thing in different ways. It's the same as the continuous paver that I showed you earlier, in the sense that all the material is located here. There's tanks. You'll see the tanks on the front for your water and emulsion, your rock, everything coming out in the back in a finished product. So there are advantages and disadvantages to both types of these applications. Being as a truck mounted paver, your advantages are your flexibility. You're able to move around, as you can see, your own wheels. You're not needing any help getting from job to job. You got smaller crews in the sense that you've got a driver and the same people working each truck on the back of the job. You've got a smaller crew. You're able to get to job easier because you simply have to drive the truck. And then the maneuverability is there's an asterisk here on maneuverability, just because depending on axles and depending on weights, that can be an advantage or disadvantage, as you see, because of bridge laws and things in each state that may cause challenges as you're moving from job to job. So when you're talking about truck mounted pavers, some of the disadvantages are the fact that every time that truck goes empty, you have a transverse joint at about every 1,500 feet or so, depending on what your pounds per square yard are. You have heavy axle loading, as mentioned earlier, that may affect maneuverability. And then this equipment is somewhat expensive, considering the fact that it's going to spend 3/4 of its life driving to and from the stockpile, because once it goes empty, it needs to return to the stockpile. It has to return and reload. When you're talking about truck mounted pavers as well, your operator does not control the speed. The driver of the truck is controlling the speed. So there's a communication requirement there needed between those two guys to make sure that we're laying an efficient mat on the back of the vehicle. So as you can see here, this is a truck mounted operation, just to give you guys an idea what that looks like for you non-contractors that are on the call today. So you'll see the material disappearing from the hopper. Your emulsion and water tanks obviously on the side there, and material coming back to place a nice mat 8 to 12 feet wide there in the back of the vehicle. So the other side of the operation, if your job or position is not requiring a truck mount, is the continuous paver. And this is what a continuous train, as we would refer to it, looks like. You've got your continuous paver. You've got your support units up front, bringing material to and from the stockpiles to the equipment. And as you can see, the guys on the back of the equipment, they are ready to lay the mat down. Looks very similar, but just to give you an idea what that train looks like going down the road. You'll see the guy walking up and down the stairs there. His job is multiple, in the sense that he's required to hook that truck up. He's required to unhook that truck when things go empty. And he's also watching the hopper and watching the cement hoppers to make sure that they're adequate in materials as they continue to move down the road, hopefully with no equipment failure or material issues, to where they can continue down the road at infinite lengths with no joints. That's one of the advantages, as we'll speak to here on the continuous paver. So like I just pointed out, fewer transverse joints when you're talking about continuous. Your operator on the back of the machine is controlling your speed, which is different. You have the guy on the front who is steering, but he is simply doing just that. He is maintaining that joint line to try to keep things straight and in line as they move down the project. For the most part, in a continuous job, you're going to be able to do more miles per day. Your driver can move to either side of that truck to be able to get the best visibility and the best options to be able to maintain those lines and those joints. When you talk about support trucks, they're inexpensive in the sense that they're only going to the jobs, to the stockpiles and back. And then with the continuous paver versus a truck paver, you're only having to calibrate once. With a mounted paver on a truck, you're having to calibrate each machine versus a continuous where you're only doing that one time. The disadvantages obviously are if that paver goes down, then you're down. You're done for the day, you're done until those repairs have been made, or whatever the issue may be, you're done until it's done. When you're moving from job to job, unlike the truck mounts, you're going to need a low boy. These machines travel at about 35, 40 miles an hour and are not street legal. Not saying it's not possible, but it's not safe to move these things from one spot to the other. You need additional crew members to perform these options because you need more truck drivers, longer lengths of road that you're probably going to do inside your closures. So more safety and regulating with road closures. And then you have one paver per job. So both pieces of equipment are applicable in any circumstance. One's not necessarily better than the other. They just may be better in that situation than the other, given the circumstances. So talking about either one of those pieces of equipment, you have two different types. You have the mechanical and you have the electronic. For the most part, mechanical units, they're being phased out in the sense that most everything in the market today is moving to the electronic side, but still they're still out there. So from an educational standpoint, we'll discuss both for these purposes. So in a mechanical or air over hydraulic system, you got a jack shaft that is powering the emulsion pump and the aggregate belt and keeping those things in the same ratio. So those hydraulic systems are operated, and they're operated by basically poofs of air that are keeping things. Each poof of air is like a counter. It's keeping that jack shaft, it's keeping your emulsion and aggregate, because all of your mix designs are based around your aggregate for the most part. So everything needs to be in relations to that. The different ways of counting your aggregate, it can be by gates, it can be by the speed of conveyors, but there are different options as to how you do things, and that's what we're discussing here with the mechanical and electronic options. So when you look over to the right side and you're discussing electronic pieces of equipment, that piece is using the computer controlled hydraulic motors, and that's separating the power, that's to separately power the aggregate belt and the emulsion pump. And what that basically means is when you're talking electronic, you're talking speed of the aggregate versus amount of aggregate that you're basing things off of. So there's always adjustments going on, and that computer's maintaining that ratio between your aggregate and emulsion in your mix design. Your mechanical paver, like I said earlier, is going to, the aggregate is going to be based off how much aggregate you're allowing out of the back of the hopper. That gate is going to move from 2 to 3 to 4 inches, and that's going to control how much aggregate you're having. Your emulsions and all those things are going to remain consistent, and you're going to control that system by how much aggregate you're pushing out the back of the gate. So you're using air electronic counters, and that's counting revolutions of that belt and that emulsion pump to maintain that ratio between the two. When you go to electronic pavers, it's a fixed aggregate gate. The same amount of rock is coming out depending on the speed of the gate, but the hole on the back of the gate is never changing. The emulsion content is controlled by that computer controller. If you speed up, it's giving you more emulsion to maintain that mix design. If you slow down, it's giving you less emulsion for that mix design. And then it continues to check and adjust the speed of various motors to make sure that we're maintaining the mix ratios consistent with the job mix formula. This is just a quick picture here of the two different setups. On the left is the mechanical jack shaft. You'll see the cranks and the chains and sprockets as you would imagine with a mechanical setup. And then to the right, I don't want to say neater, but more you would imagine this with an electronic system as things evolve, where you've got your checks and balances, you got your emulsion pumps, you got everything in a nice neat box there and being pushed by the hydraulic units. So as we have truck mounts and we have continuous pavers, we also have different computer systems to be able to help us through the process to make sure that we're doing these quality projects in any particular circumstance. So you have a monitoring system on the left, which is it's basically capturing the information with those counters that we discussed earlier. It's capturing that information, but whatever information you're putting in is capturing, whether it's good, bad, or indifferent, that's the information that is catching. It's going to give you, at the end of the day, it's going to give you a visual and printed report. It's going to be able to show you the quantities that you used, all the percentages, and the square yards applied. In the same sense that whether those numbers are right or wrong, that's what it's going to give you. When you start discussing a computer mix control, so what that's doing is you input your mix design, the parameters which you're trying to do the product, and it is not going to allow you to be outside of those parameters. So there's where the control comes in. You still have control of your mat. You still have some options with how your mat's going down and what you're trying to accomplish, but it's going to make sure you maintain the ratios of emulsion or water or additives, whatever it may be, that you're complying with what the owner of the project has requested and been approved for that project. So that computer controls speed of the conveyor and the pumps to maintain that design. It's adjusting to the changes, and it's always making those changes to make sure that we're retaining that information that we gave it earlier to stay in that mix design. And it's also tracking your distance and your width, which is allowing us to put down that total square yards or those pounds per square yard that we need at the end of the day, which most owners are looking for. Here's just a picture here quickly of what a control system would look like. You can see up in the right, you've got some engine diagnostics that are going on there just to give you for troubleshooting. If you look down in the left there to material totals, it's giving you an idea of what you've ran through for the day. That's a running total that you can clear when you need, but at the end of the day, most agencies will accept that and use that as their pay items. And then you've got your ratios at the bottom, your mix designs that you're trying to maintain as you're going through the day and putting that mat down on the job. So besides the machine, the second part of the equipment standpoint is the box on the back of the machine, which I pointed out earlier. There are different options depending on what you're trying to do. One would be your Slurry Box, which is a lighter box, expandable to different lengths. You can do it with no augers. You can do front or dual augers, obviously, but with a Slurry Box, because of its weight, it is slurry only. Versus you have your hydraulic spreader boxes, which are all dual augers. They can perform with slurry or micro. To expand the widths or decrease the widths with those boxes, you must stop and take certain kits out to bring those joints down to the width that you're trying to perform. And then you have your variable width spreader boxes, which are also dual auger and can do slurry or micro, and they're adjustable on the go, which I'll show you pictures of later on how that's performed. And then of course your Rut Box, which is specific to job descriptions or needs depending on the situation of the road that you're trying to perform on, and we'll show you the parameters of the jobs that sometimes require those Rut Boxes to be needed. So here's a picture of your basic Rut Box or Slurry Box. Very simple. This is a single auger situation. Lightweight, looks to be 13, 14 feet, and is doable in most applications or all applications of slurry. So here's a different type of micro spreader box. You'll see it's a little beefier. You're looking, the back of the job is obviously at the top of the screen there with the mat going down, dual augers. I'll show you a video here in just a second. Augers are always trying to move material to the back of the box to keep it from building up in the front, as you can see in the photo here. And here's a video that we'll show of the spreader box operation. Two things to show you in this video. One being that obviously the augers are moving, as I spoke of earlier. They'll be moving the material to the back of the box, which again is on the top of the screen. The second thing being that the material being shown in this video is actually a little to the wet side of what we would prefer. You can see the material coming out the front of the box in the beginning of the operation there as they try to thicken things up, but it's a perfect level in the sense that material is right to the shaft of the box and things are proceeding as you would expect as they move forward. So here's our variable width spreader box. You'll see the steering wheels we see there. What those do is allow the secondary screed, as you see in the back, with the 4 to 5 inch rubber on the back there. That allows us to go up or down on the job, depending on crowns and depending on flow out the sides of the box. If you look up to the left and right around the gentleman's head in the blue versus the stop sign on the left, you'll see some toggle switches there. And what that's allowing us to do is be able to move that equipment and that box. It's allowing it by hydraulics to be able to expand on the fly as we move up and down the road and adjust the curbs or outlets, whatever it may be that we need to move to and from without having to stop and take pieces out or move the truck and come back and do handwork, as we, with any quality job, prefer to do as little handwork as possible. So here's the Rut Box that we discussed earlier. As you can see, a little different design. They come in 2 different standards, which is 5 or 6 feet. A little different setup with the augers. As you can see, the augers, everything with the augers in a Rut Box is trying to move that material to the center of the box where that rut may be located. And the purpose for that is to try to get the larger aggregates moved to the center, so the larger aggregates will fill the bottom of the rut. That's key in any time where these units are called on to perform, because we want the larger aggregates to build that foundation to be a cornerstone for what we're trying to do in leveling out those ruts that may be in the previous application that we're correcting. So when we're talking about ruts, there's a cross section that's deformed 1/2 inch or more that should be treated with microsurfacing in a Rut Box. If the depth of that rut exceeds 1.5 inches, it may be advisable to use a larger aggregate than the rest of the project requires. But the rut filling is normally accomplished with a type 3 or greater aggregate gradation, meaning the larger the type 1, 2, or 3, the larger the gradation we're going to be calling for in that mix design. So the deep lifts may be constructed on the low side or the optimum asphalt content range. So when we use a Rut Box, we allow the largest particles of aggregate to be channelized to the deepest part of the rut, which is illustrated here in the cross section. You'll see the finer stones are flowing out to the outside of the rut, and we want those larger stones filling that center zone where the rut actually applies. So if the contractor should add an 1/8 to 1/4 inch crown on top of the rut, we basically want to fill it up like a pie, like a kind of like a cupcake, kind of overflowing a bit, to be able to allow for the traffic to come back in for our compaction at the end of the project. So anything 1/2 inch and over, just to emphasize, we need to require a Rut Box on the project. Here's a short video. It's basically just showing you what we discussed earlier with the different crowns and different things going on with the job. This guy on the back of the machine, he's going to be turning those wheels, and it's not big turns, it's small adjustments, 1/4 inch, 1/2 inch at a time, if that, just to maintain that even mat as the material's flowing out of the back of that box. That's the advantage of that secondary screed as we move down the road. So of course, the equipment's only as good as what you take care of and how you treat it. Some things you would look for at the end of the day or during the project, as a matter of fact, is cleanliness. You want to clean your pug mill nightly. Some units have slide out pug mills and different things that allow that to be done easier. You want to touch your spreader box, no matter which kind you're using or working with. You want to touch that spreader box basically every time you stop. If you're using truck mounted equipment, you want to stop, you want to clean, you want to get those corners clean and try to keep those augers as clean as you can. And of course, at the end of every day, you want to break down and clean that equipment as much as possible. And then you want to look for things under the equipment with your aggregate spillage, under your feed belt or your mixer, and of course under that front harbor rubber, which could cause trails in your mat, different things to develop as you're moving forward that just cause you to have to touch the mat more than you would want to clean those type of things up. And then of course, if you've got a liquid leakage, meaning hydraulic oil, fuel, anything, emulsion, that's going to cause that material to be unable to stick to the virgin ground that we're preserving, that could cause problems that you want to address and keep an eye on as you're moving forward. So with the spreader box, like I mentioned earlier, we want to clean that thing often. The augers stay within 1 inch of a roadway or as low as possible. Those things will wear over time, so that's something to keep an eye on. You don't want any foaming or splashing mix in that spreader box when we're going down the road. Oxidation could cause things to break earlier or later as the project moves forward. That front rubber, to keep that material, as we saw in the video, you want to make sure it's not moving forward and out of the box. You want to maintain it with different parts or requirements that to keep that material in the box as much as possible until you're ready for it to come out the back. And then, of course, your rubbers and urethanes are always wearing, as their friction is causing wear as you're moving up and down the road. So I'm not going to go deep into materials, but you need to understand what the system is doing. It's break, set, and cure. It's doing all this chemically, and it's doing it quickly for the most part if things are being done right. So it's a chemical system, and the component is an important function in the system, which those components include the things listed below here, which I'll discuss in detail just for a short minute, which are the aggregate, your emulsion, your cement, your additives, and not to be left out, and maybe one of the most important things is your calibrations, because without that, your quality of these other products doesn't matter if your calibration is not correct. So when you're talking about aggregate, you're obviously talking about gradations. You're talking about your acidity, your compositions of the rock, different things that you've done with your mix designs to make this particular aggregate appropriate for the project that you're performing. So you're not really worried about the top side of the rock. You'll get some top size issues that can be pulled out of the mat or from, as we talk about in cleanliness at the bottom, from your loader not performing his job correctly. But when you need to start paying attention is if you talk about your 8 and your 4, they'll go coarse, which can cause some raveling and some noisy rides. You'll have those rocks popping up under your vehicles. The most important thing we can talk about when we discuss gradation would be the 200. The 200 is a smaller portion. It's your dust. It's your things that are allowing more products to be stuck to or adhered to with your emulsions and your waters as you're putting the mat down on the ground. So if you don't have enough, you cause the system to flush. If you have too much, you cause the system to be too fast. Not one of these problems is necessarily worse than the other. They both bring their own challenges. And as I mentioned earlier, make sure your operator's staying out of the bottom of that pile. You need to assume some waste whenever you're stockpiling a job because you do not want to be scraping ground and getting rock and other virgin materials mixed in with the aggregate that we're trying to produce with. So when you talk emulsion, the optimum temperature for the emulsions between 80 and 110 degrees. Anything under 75, you may see some separation or some shear. That could happen during storage if you allow your material to sit too long before usage. If it comes in too hot, meaning straight from the factory and hasn't had that chance to kind of cool off to get to that temp that we're looking for, it could cause that break that we just discussed earlier in the box or right out the back of the box. It's a little too quick for optimum procedures when we're trying to put the mat on the ground. So when you talk separation, you may get small amounts of separated latex, but that's okay. You're just looking for the large strings coming out of the tanker. That's obviously a problem that needs to be addressed. You want to see that if you see large strings of latex in the spreader box, you probably need to shut down. This says ship the load back. There's obviously conversations that need to be had with your emulsion provider in ways that can be addressed. It's not good. Most emulsion providers are going to be aware of that before it even happens and be taking care of that situation. So that's where that relationship comes in with your providers and being able to communicate throughout the process as the day changes and cloudiness versus humidity and rain and sunshine. All those things could affect how this stuff's reacting once it gets to the job site. So with cement, you saw a picture earlier. It's pallets of cement on the top of the unit. It's a small percentage that we're introducing to the mix, but it's a very important part of the process. It's giving you that thicker, creamier mix, and it's keeping that water from separating in the spreader box. That's obviously we're trying to keep two things that don't like each other together. The cement is giving us that opportunity to try to bond those things quicker than they really want to by breaking down that pH or causing that pH shift. So you can adjust your cement percentage, as I said, during the day, depending on how things are reacting, being cloudy in the morning, cooler in the morning, hotter in the afternoon. As the climate changes and your environment changes, Cement's always one of those things that's going to move up and down throughout the day, depending on how things are reacting. The key to talk about cement, it does not make the micro brittle. It's not giving it that crustiness, and it is not adding strength. It is simply just it's an option for us to be able to allow things that chemically don't like each other to be able to bond and on a first date situation, get to know each other better. So no better way to put it. So the next part is calibration. So why do we calibrate? We calibrate because we're trying to deliver a precise ratio of emulsion to aggregate. That's the key to our mix design, is our emulsion and aggregate ratios, and then our mineral filler to aggregate, as specified in the mix design from the laboratory that we've used for this JMF. By doing this, the contractor and buyer, they know what they can expect from the mix, because tests have been performed in the lab on a mix with the same ratios. It also allows a precise record of the amounts of material that were applied on the project for payment purposes, which is another key ingredient to performing a quality project. So as we discussed, we're calibrating to make sure the mix matches the design. The aggregate and emulsion are staying together in the ratio. Reasons to recalibrate, this is up to contractors on how often they do this, but we as equipment manufacturers would say you must recalibrate if you have material change, if your source is changing from your emulsion or your aggregate, if you've had any kind of repairs to your equipment, being even a repair or a change, and then if you've had to replace any conveyors or anything delivering material, now's the time to recalibrate. We recommend emulsion should be calibrated every job, or at least once per month if you're not changing out your emulsion provider. So when we calibrate, we're trying to take a batch mix design, which is like a concrete plant, and we're trying to turn that into a continuous feed process. The aggregate and emulsion, they're mechanically or electronically, as we discussed earlier with the different types of equipment. We're doing it different ways, but we're trying to do the same thing to get to that mix design ratio. In some pavers, that's fixed gate, be it 2, 3, 4 inches, whatever your calibration required, or in others, it's electronically by the speed of the gate or by the speed of the aggregate, and everything's adjusting according to that. Here's a small example. If you're talking about batch, you've got a 10% of emulsion, or 10 pounds, versus 100 pounds of rock. So that's an easy example of a batch plant. We're doing the same thing every time. We're producing that material and we're moving forward. If you want to go with 12% emulsion, you would add 12 pounds to every 100 pounds of rock, and that gives you 12 pounds of emulsion. On the left, which would be like a small cement mixer, you can see that you would put each percent of those ingredients in there. What we're trying to do is convert that to a continuous flow mix design, which you see on the right, where new material is always introduced and your quantities are always changing. So what is calibration? Calibration is the process to the actual output of the machine is measured by weight for the ingredients of aggregate, emulsion, and mineral filler. The actual outputs are correlated to the revolutions of the conveyor, of the aggregate conveyor. They're correlated because the laboratory specifies all material ratios by weight to the amount of aggregate. Aggregate is the driver for our mix design once it comes out of the laboratory. Everything is based around the amount of aggregate we're putting in the mix. And we do this with the use of counters. So here you see a cross section of the hopper. You got your rock and your emulsion. You got your head pulley at the right. The bottom right there is your head pulley. It has 2 triggers. Therefore, it'll register 2 counts per revolution of the head pulley. The diagram also shows the emulsion pump, and we'll talk about the emulsion pump here shortly. So here's an inside diagram of the emulsion pump. It uses 2 gears. It uses a drive gear and a driven gear. The drive gear has an external shaft and it's powered by an hydraulic motor. The driven gear turns by engaging the teeth of the drive gear. So they're moving, one's moving the other. As the gears turn, you'll see the materials moving in the inlet port being moved clockwise on the top and then counterclockwise on the bottom to get to the outlet port. So as shown in this cross section, it's present at the inlet port of the pump. As the gears turn, the emulsion is trapped between the gear teeth and the external case of the pump. In the outer port, the gears start to mesh. The gear teeth take up the space the emulsion has been occupying, but that emulsion is therefore forced out of the outlet pump. So it's a positive displacement system when we're referring to emulsion pumps. So here's the back end of a hopper. When we talk mechanical or electronic, they basically look the same in the sense that when you talk about your gate, in a mechanical system, you could be 2, 3, 4-inch gate, your aggregate coming out on top of a conveyor. If it's a electronic equipment, that gate never moves and the speed of the aggregate will change your ratios or change your amount of material going into your mix. So here's a picture. Since the deflation of the emulsion pump can't be changed in this photo, this is a mechanical machine, the gate setting of the rock hopper is changed. So that will go up or down. If you lower the gate by bringing less rock into your mix, remember with the mechanical equipment, your emulsion's not changing. It's the amount of rock that's changing. So if you lower the gate to decrease your rock, then you're increasing your emulsion. Versus if you raise the gate, then you're going to increase or decrease the emulsion going into your material. So in this example, the gate's set at 4 inches. If the conveyor turned for 10 counts, then it's 100 pounds of rock delivered. During the same 10 counts, the emulsion pump delivered 10 pounds of emulsion. So that results, easy math, that results in 10 pounds of emulsion going into the system. If we lowered that gate to 3.3 inches, delivered the same amount of aggregate delivered 83 pounds of rock by lowering that gate and the same amount of emulsion, what we have there is a 12% rate of emulsion into that mix. So we're constantly processing that material. It does not, I need to reiterate, we are not, the mix design is in a batch and we are trying to convert this. So the current design continuous feed designs, which means those raw ingredients that we discussed, asphalt, emulsion, water, they're continuously delivered to the front and it's a homogeneous mix and all these ingredients are continuously delivered to the spreader box from the pug mill. Since we have a continuous feed, the feed rates of the aggregate, the emulsion, and the fines must be tied together to ensure proper ratios of materials at all times. This is commonly performed with a jack shaft arrangement in mechanical or a hydraulic series arrangement. These feeds are tracked with our counters as we discussed earlier. It's important to note that a continuous feed is not to be confused with a continuous paver. In a truck mounted operation, the materials are fed as described above, but the paver paves until the paver is empty and then returns to the stockpile for refill. In a continuous pave operation, the materials are fed to the described, but the paver stays on the job while the mobile support units are moving material to and from the unit. So moisture can be used in the calculations by performing calibration. There are several ways to determine this content. In the field, you take a sample of rock, it can be taken and weighed and spread out on a cake pan or allowed to dry, then reweighed. Let it dry more and reweigh. You basically do this process until you come back with the same weight continuously, meaning all the moisture has been removed from the product. Another field approach or bush approach would be to have the lab weigh a common volume, such as a coffee can or cup of dry rock and note the weight if it's the same aggregate. While in the field, you'll only need to weigh the wet rock in this known volume to make sure to subtract the weight of the coffee can or cup to perform the calculations. So you're taking your weight of your wet rock minus your weight of dry rock and dividing that by your weight of wet rock, and that's giving you your moisture content. Very important to track this daily, as we all know things change with stockpiles, with thunderstorms during the summer, during our paving seasons. Moisture is always on the change, and it's very crucial to our mix designs as to know what that number is. So real quickly, we'll roll through this, but for calibration steps, you're going to get your tare weight into your container. You're going to do this a couple of times. You want to repeat this at least 3 times by weighing either the container or the paver and divide the weight in pounds by the number of counts that you'll get by the computer or the counter in a mechanical paver at the same time. You want to make sure you get 3 results that are all within 2% of variation. Same thing with rock, same process. You'll run through this 3 times, maintain within that 2%. As you'll see here with rock in your mechanical equipment, with your adjustable gates, you need to do this 3 times each at 3 inches, 4 inches, and 5 inches. So it takes a little time in mechanical equipment to be able to calibrate for aggregate. You're going to graph those aggregates per count. You're going to obtain your desired emulsion content per your mix design, and then this will provide you with the desired aggregate weight per count. It's very confusing. Most of you guys won't ever see this. For you contractors, you do this in your sleep, so we won't spend much time for those that are confused. Here's a simple graph. On the left, you'll see something that's done electronically, and then on the right, the old school graph that you're charting out to make sure you've got that straight line graph through the means or the medians that you're looking for in that mix design. So you can also use this double check as an agency or as an inspector. You can use this information to check the calibrations. Let's assume 4.5 pounds is what your emulsion weighs. Your aggregates weighing 38.4 pounds per count. Take those numbers, take a known length of 1,300 square yards. Just for this process, we'll assume a count of 356 and 1120 on those counters that we saw earlier. And say 764 counts gives you your pounds. Take those pounds, and my apologies for rushing through this. As we said earlier, this will be on, if you have any questions, we can roll back through this later as it'll be advertised on ISSA. But you take those counts, you come out to 22.01 pounds of aggregate application rate. Take some of that same math, divide by your pounds of your emulsion to get your 12.5%, which is what your mix design calls for. Combine those two numbers to get your application rate of a hefty 27.5 pounds per square yard. So this is a good way of being on the job, especially with electronic equipment. This information is provided pretty accurately, and you can spot check as you're moving up and down the road with the equipment. So when we talk about preparation of the road, there's a few things that are done before any micro job is done or any correct micro job is done. One of those being crack sealing. When we're doing crack sealing, we want to keep it flush and minimal of overbanding. If we've got a 1/2 inch crack, we don't want to be 6 inches wide and cause that banding, which can be caught by the box. You want to try to give it 30 days if you can for your surface prep to give it time to heal and be ready for those pieces of equipment to run over and put the mat down. Patching, we want to obviously, it does a great job of filling lower areas, but if you leave a bump when you're patching, then your micro is going to reflect that same bump. We've said it numerous times in different presentations and opportunities, but it is what it is when you talk about micro when it comes to bumps. And then there's several areas that are doing a good job of micro milling, Minnesota being one of them. They've had some success with their freeze thaw cycles up there, where it smooths the road and allows that texture to increase adhesion of the micro surface. So anytime you get a chance to micro mill, that's a good option to have when we're talking micro in the field. And then of course you're cleaning your project before you start. Brooms, blowers, whatever it may be. You need to look out for your field entrances, your places where vehicles, depending on a lot of these jobs are in rural areas, people coming out in places unknown, bringing dirt and debris into the field. Rock shoulders can always add debris to the site, and then areas around the loading site. So there's different paving techniques that are done. You'll see here when you start talking about joints, they got proper alignment with their mat. It's a uniform surface texture that they're performing the job on versus the existing or the previous spot they've been. They got some oversight on the right, as you can see. I hope that's a good conversation going on. The guy on the right doesn't seem to be paying much attention, so who knows? And then we get into longitudinal joints, which is that center line that's so important in performing the process. And it's straight or tangent lines. They need to be uniform, following the traffic. They need to be constructed as an overlap or a butt joint. And if you're doing an overlap, it needs to be kept at a minimum of 3 inches. Smooth and neat in appearance. And we want to keep from having excessive buildup or uncovered areas. So here's a continuous run machine equipped with an expandable spreader box. It's an acceptable joint that's smooth and neat in appearance and has no excess buildup or uncovered areas. You'll see the two guys really focusing on that center joint there, making sure that everything's aligning correctly. So on the left, you can see the proper construction of a butt joint. On the right is the finished product. So I think we would all walk away happy with a project that looked like that. And then you got unacceptable situations here. You've got contributing factors may be it could have been poor box maintenance or leaking. It could have been inadequately workforce, inadequately trained. Could have been moisture in the mix, or it could have been lacking moisture. There's so many things that could go into situations that look like this, and we've all seen them at some point. So when we talk transverse joints, they should be smooth and neat in appearance, and handwork should be kept to a minimum. Excessive buildup or uncovered areas should not be permitted. So when possible, you should be constructed as a butt joint rather than an overlap joint, as we discussed in our longitudinal joints. The use of roofing felt may assist the contractor in constructing acceptable transverse joints. So the edge of the spreader box should produce a straight and clean edge. As you can see with the painted lines, the guy's got his drop chain there to help him stay straight. Or on the right side, you'll see a guy pulling line. This is also acceptable. On rare occasions, the mixture may have too much liquid in the system, which may cause flow and runoff onto the shoulder. Operation should be stopped if the mixture is maintained, or if we can't maintain proper consistency to adhere to these joint lines. You'll see unacceptable pictures here on the left versus the right. That's pretty self-explanatory. The picture on the right will illustrate proper alignment. It's a stable mix with good equipment and the use of an adequate guideline. So factors that will influence final surface texture, you've got existing pavement surface texture. As we discussed earlier, we're as good as what we're going on. Your mix consistency or accurate calibration, your adherence to job mix formula, the type of screed rubber you're using or length could affect that. Your spreader box maintenance, the use of drags or secondary strike off, your application rate, the speed of application as to how fast or slow you're putting down that could cause washboarding, opening to traffic too early, and or rolling if required could all affect your final surface textures. So here we see a continuous machine equipped with an expandable spreader box. Proper spreader box maintenance and operation along with proper mix consistency are two items that are essential in providing a uniform surface texture as seen here. That's a good looking map there on the back of that machine. It's important to remember that slurry systems have an aggressive surface texture, and when applied properly, they can maintain that high friction surface that we're looking for the duration of their life. If you see the uniform surface texture being constructed on the left with a more magnified view on the right, it's important to note that the entire width of the system should look the same. They should have a uniform surface texture. So some possible problems or defects we could see from laying micro slurry is bleeding or flushing, surface loss, raveling, or even rutting that we could self-induce. So bleeding can be caused by the excess asphalt in the mix. It could be that could be brought on from a calibration issue, or it could be a paver issue. It could be a pump issue. You could have lack of fines in the mix. There may not be enough surface area for the emulsion to stick to. Your application rate could be too high for the gradation, or you could have an incorrect emulsion on the project. So when you talk about debonding or delamination, these are some things that usually call that, meaning poor surface preparation, which we've discussed earlier. You could have contamination from the paving process. You could have some larger objects in the mix that are causing problems and causing surface loss. The mixture could be breaking or curing too quickly, or you could be facing debonding or deterioration. So this is not good when you're talking about a surface loss. So debonding from the underlying surface can be caused by, this could be caused by vegetation. It could be animal carcasses, obviously not being, there'd be a lump. If you live in the South, look like an armadillo. Loose aggregate or soil, The equipment could be leaking oil or fluid, or dry aggregate could also contaminate the surface. And even snow plowing can cause debonding at high spots in existing pavement cross sections. So this photo is an example of what will occur if the pavement is not prepared correctly. So a slight amount of raveling is normal within the first day or two. You should not, when you're driving down the road after a couple of days, should not hear the rocks hitting the bottom of your car as you move down the road. And we'll see raveling more common up in our cooler temperatures as well. So raveling occurs when those larger aggregates dislodge from the surface and the aggregate lacks sufficient embedment in the matrix, or it's the quantity to hold a larger aggregate. Poor quality aggregates may debond. It could be an aggregate issue. It could be an application rate that was too thin. The matrix could have a lack of fines to fill voids between larger aggregates, or we could have premature opening to traffic, or even a summertime storm that could pop up on us before we had time to cure. It's just some of the things we were discussing earlier: cooler temperatures, the premature opening. So, and then again, rutting, which is something that we're trying to fix in these processes, we can also face at the end of a project, being that was the micro surfacing level at completion. Should the road have had more applications before we started? Should it, did the contractor put the rut in the mat themselves? Did they get on the road too early and not put enough material in those ruts to fill them? And is the underlying surface continuing to rut? Did we meet the job mix certifications, or the things required in the project? And as we discussed ad nauseum, is our aggregate and emulsion meeting our mix design to be able to fulfill the obligations that we have on the job? So these are a bunch of things that we've discussed. We've gone through it, a lot of information extremely quickly. It's kind of a 30,000 foot flyby of the things that could cause you to do things right or wrong. I know most of our contractors out there are doing this on a daily basis and performing above expectations, but we just wanted to bring this out and just show you our view of what it takes to be successful. And like we said, it starts with your materials and your calibration keyword there. You can have all these things and do them correctly, but if your calibrations aren't being kept up with or being done correctly, none of this is going to matter, and you're going to be fighting things throughout the process. So there again, that concludes the presentation for today. I appreciate your time during our lunch hour here. I appreciate the opportunity to be able to share some things with you guys, and I'm available outside of this for any questions or comments that you may have, and look forward to seeing you guys soon once the travel bans and things hopefully get back to what we now consider normal. So thanks again for the opportunity, and now it's time for questions. Thank you very much.
We have a couple questions. Tyler, both questions we have so far go back to the beginning of your presentation when you were talking about truck mount versus continuous pavers. So the first question, can you verify the speed of a continuous paver? Someone asked, is it accurate to say that a continuous paver can only move about 15 to 17 miles per hour?
No, it can move. You definitely wouldn't want to pave at 15 to 17 miles per hour. It can move up to 30 to 35 miles an hour. Like I said, it is not street legal. There are no seat belts. That is not something that is recommended. When you're moving that product from job to job, a lowboy is what would be required. Not going to say that's always the case if locations are close. But it can exceed 30 to 35 miles an hour and pave. Your pavement is being tracked. An electronic piece of equipment is being tracked by the radar. In mechanical, obviously, that's a different scenario. But yes, it can exceed those parameters.
Okay. All right. And how about if you were to, in terms of lane miles for a truck mount versus a continuous, how would that comparison look?
So obviously, there's a lot of parameters to that answer, being if you're doing a subdivision or if you're doing city streets versus rural highway. If to compare apples to apples, if you went on a rural highway where you could close 4 or 5 lane miles at a time, you're probably going to get, you're going to do 1.5 to 2 miles with the continuous paver versus a mile with the truck mount, simply because as long as material's moving and the equipment is performing, that continuous paver is never stopping, versus truck mounts every 1,500 to 1,700, depending on what your application rate is. Depending on those that you're going to stop, you're going to have to create a joint. You're going to have to back the truck mount up. You're going to have to potentially wait on the other truck mount to arrive. So there's a lot of parameters that go into how fast. And there's guys that do it great. I don't want to make one sound better than the other, but logistically speaking, a continuous paver is going to outperform in lane miles versus truck mounts because of the availability of material and that process to continue.
Okay, and how does speed of the paver affect the quality of the job?
So obviously every contractor wants to go fast. They want to perform the project. They want to get done with the project, but at the same time, they want a quality project. As we discussed, if you start going too fast, no matter how good your material is, you can cause washboarding with that material, which is, you could get chevroning. You could get a lot of things going on in that mat that may not show up immediately, but will show up once the product is cured and broken. So there's a fine line there between being fast and effective and just careless with how fast you're putting the mat down. So speed does affect the quality at some point, and the mix design usually affects what that breaking point may be.
Okay. All right. How about, there's a question, it's two-part, but on the same topic. For micro, is it best practice to tack prior to micro and to roll after placement? And is this the most common practice for highway applications?
So there's two parts to that question. One is the tack. That, from what I have seen in my experience, is dictated by the owner. I don't know. I am not aware of any testing or anything that has shown the effects of doing it or not doing it. There's obviously, you have your virgin oils in your mix designs. Tack would not hurt depending on the circumstances and the situation of the product that you're putting the mat down on. And what was the second part of that question? I'm sorry.
No, you're rolling after placement.
Yeah, so we see rolling in certain parts of the country. What I would say to rolling is the best thing you can do to roll the project is put traffic back on it when it's ready. They're basically performing the same operation. You're getting the same results. You know, we like to say, or not like to say, but we say in this industry, the worst time to view a micro or slurry mat is when it immediately goes down because it hasn't been ironed out. So you can add that to the contract. You can do those things with a roller, rubber tire roller, whatever it may be, but you're going to get the same results by opening that lane up to traffic and get the same results over time.
Okay, great. Well, that takes care of the questions for the most part. So thank you so much, Tyler, for taking the time. I thought that was a great presentation. And I just wanted to bring to everyone's attention that the leadership development team is hosting another webinar sometime this fall on crack fill treatment. So please be on the lookout for communication regarding our next webinar. And hopefully you'll join us again then. So thank you for joining today, and thank you, Tyler, for taking the time to present on this topic.
Thank you so much. I greatly appreciate the opportunity and look forward to seeing everybody soon.